particle. Both are having same charge. Now what is the initial separation between them? He has given 1 meter. So call that as x naught. I'll release it. There the friction is also acting. So how the electrostatic repulsive force will act like this. And the friction, you can show it in this direction. So because of friction now, so initially let's check the electrostatic force, like what is the limiting value of friction? Mu mg. Check that and look at electrostatic force, initial value, K Q square by x naught. So definitely this Fe will be greater than Fl. If you want, you can cross check that. So therefore what will happen to this charge particle now? They'll accelerate because the electrostatic force will be greater than the frictional force. So as the separation between them increases, then the magnitude of electrostatic force will decrease. So somewhere at a point, let me choose this one. So here the electrostatic force acting will be Fe dash, you write it, because the distance has varied. Now where it will be equal to the friction. So what type of motion it will describe now? Since Fe greater than F, so it will accelerate. So due to acceleration, speed increases. So at this particular point, I'll say that it will have maximum velocity. You can straight away, sir, why the word maximum you're bringing? Very next moment. So here, what is Fe dash? Fe dash is just equal to F. Very next moment, the electrostatic force which is acting will be less than the frictional force. So what type of motion it describe? From ear to ear, it will be accelerated motion. Clear this. So now after this, it will be retardation. So definitely if you calculate this velocity V, no, let it be V. This V will be less than Vm. So definitely where the maximum possible when net force is 0, no. After that, it starts undergoing retardation. A double dash, you put like this. So when the maximum is possible, when the electrostatic force becomes equal to the frictional force. So we have to calculate this maximum. Okay, how to bring that? You can directly go for the, sir, and find out the acceleration, Fe minus F is equal to me. Then I'll integrate. Yes, you can do that also. Can we apply conservation of mechanical? I'm interested, bothered about the energy aspect here. Can we apply conservation of mechanical energy here? Definitely answer is no, because what is frictional? The frictional force is acting, no? And what is the frictional force? Non-conservative force. So I'll release them from rest. From rest, they're released initially. Do the likewise. So can we apply at least this, the work energy theorem? Work energy theorem, can we apply it? So here, what all form, overall energy will be conserved, no? Not conservation mechanism, overall energy will be conserved. So I'll directly take help of this one. So initial energy of system, K Q square X naught is equal to, then finally what happened here, K Q square X plus kinetic energy of the particles plus work done by the friction. So what is the work done by the friction? Friction into x minus x naught. So how to calculate this x that we don't know? So I'll take help of this. Fe dash equal to f. So this should be equal to k q square by x is equal to mu mg. Solving this, I'll get the value of x here. X will be k q square mu mg. A very simple idea-based problem. Very simple idea-based problems. So I'll get the value of x. That value of x, I'm going to substitute here. I know already x naught is given. So what is x naught? X naught is 1 meter. Mass of the thing 0.1 kg. So all this data we know, substituting that. And we know the friction force also. It will be. So getting that, we'll get expression for that. This is a maximum, no? I'll write Vm. Between what points I applied? Between the first and the second diagram. For figure 192. Okay, solve this and verify. Let me just give all the basic ideas. See, there's nothing wrong in thinking about energy. So I didn't apply conservation of mechanical energy here. So what I applied? What is the energy? What is the initial energy of system? Electrostatic potential energy. And the decrease in electrostatic potential energy, what will get converted? A part is used, a part will be converted into kinetic energy of the blocks. Remaining, what will happen is used to overcome the friction. Its overall energy will be conserved. So you can apply. You can apply. Sir, I'm not getting this idea what to do. If you don't get idea what to do, so you do one thing, go take help of the kinematics. Ma is equal to Fe dash like a Fe minus F. Then define the electrostatic force when separation is X. Then integrate. Then work out here. So you'll end up with the same answer. So I feel this will be a little bit easier for you. No need of any integration. Not like you look at that Fe is greater than FL. No, initially you check it. Anish, you can start from here. The initial Fe will be greater than FL. So what will happen to the body? The body will start accelerating. Then as it starts accelerating, the separation will increase. As the separation increases, the electrostatic force magnitude will decrease. At one instant, the electrostatic force will become equal to the friction. In that instant, the particles will have maximum velocity. After this, what happened? Why the static friction should not act here? It should be a kinetic friction only. Go back here because of velocity. It's not at rest. The particles are having velocity. So what is this friction acting? Will be kinetic. I think good observation. You can. I'll just put it here. This F, what is acting is a kinetic here. When do the static friction will come? When the particles will come to rest here. So they're in motion, no? So the friction acting will be kinetic. Got the idea? So this is not because of velocity, it will be still moving. Why that maximum word is brought? Because of this condition. Because V will be less than Vm. And here it was a test, the speed will increase. So here only maximum speed occurs here, second diagram. Okay, this F is kinetic. So you can write this total F is kinetic, what all we are discussing. When static will become, when they come to rest, static friction will act.